So today we're going to cover the last part of section 4, and today we're going to use or learn the quadratic formula. So when we use the quadratic formula, our equation must be in standard form. So we need to have the x squared first, then the x term, then the constant, and set it equal to 0. If it's not in the correct format, you're not going to be able to get the correct a, b, and c value. The a that we're using in this formula is the coefficient of the square term. The b is the coefficient of x, and the c is the constant. The formula is x is equal to, and you can either think of this b as being the opposite of b or negative b, plus or minus b squared minus 4 times a times c, and that's all under the radical, divided by 2 times a. Now, a lot of students prefer this, but if you don't follow order of operations and watch your signs, sometimes the formula can be tricky. So let's just do 5 quick examples using the quadratic formula. So the first one, it's already in standard form for me. I'm going to go ahead and write the quadratic formula up at the top. You will need to memorize it. So again, opposite of b plus or minus b squared minus 4 times a times c, all divided by 2 times a. So let's identify our a, b, and c from our equation. My a is the number in front of x squared. It's a 1. When I pull the letters out, I'm pulling out the sign as well. So my b value here is negative 4, and my c value is positive 2. I now take these 3 variables and plug them in. So the opposite of b, or negative b here, is going to be positive 4 plus or minus b squared, so negative 4 squared, minus 4 times a times c, all under the radical, divided by 2 times a. So now I'm going to go ahead and 4 plus or minus 16. Now, what I like to do when I am dealing with these 3 numbers that are here, the negative 4ac, what I do is I treat that as a negative 4, and then I multiply negative 4 times 1 times 2, and that gives me negative 8. That's just my preference. If you'd rather treat it as a positive 4, and then remember this subtraction sign is still there, you can do that as well. And then 2 times 1 is 2. I now need to subtract what's under the radical. 4 plus or minus 16 minus 8 is 8 over 2. Now, key important thing here. Do not be tempted to simplify this right now. You must simplify the radical first. So I need to break down the square root of 8. So the square root of 8 is going to break down into 2 times 4. If you're good at recognizing that 4 was the perfect square, it just becomes 2 radical 2. So now my simplified is now 4 plus or minus 2 square root 2 over 2. Now I can look to simplify. That 2 that's in the denominator needs to be able to divide into both of the numbers that are outside the radical. So I can simplify it, and I can say that 2 goes into the 4 2 times. So I can change that 4 to a 2. And then 2 also goes into the 2 1 time. You need to be able to simplify it with both. So then now my final answer here is just going to be 2 plus or minus square root of 2. When you go to key it into WebAssign this weekend, it's going to ask you to split them up. So you're going to key it in as 2 minus the square root of 2. And I believe they're going to tell you to separate it with a comma. Just read, or sometimes they give you the 2 separate boxes, and then 2 plus the square root of 2. Again, we're keying these into WebAssign in simplest radical form. No decimals. Pretty good on the first one. Let's try number 2. Same thing, we're just plugging in our A, B, and C. So for number 2, it's already in standard form. I don't need to change anything. So my A value is 1, my B value is -3, and my C value is -2. Remember, you're taking the sign with it. Now let's plug it in. So opposite of B, or negative B here, would be +3, -3 squared, minus 4 times A times C. This is all under the radical. This is actually called the discriminant. If you ever see that word on a standardized test. And then 2 times A. I now need to simplify what's under the square root. So -3 squared is +9. And again, I'm going to multiply this as a -4 times 1 times -2, which gives me +8. All under the radical, divided by 2 times 1, which is 2. I'm going to add what's under the radical, and this gives me 3 plus or minus the square root of 17 over 2. I cannot break down the square root of 17. I cannot simplify anything there, so I'm done. And again, on WebAssign, pull it apart. You would enter it as 3 minus the square root of 17 over 2, and then 3 plus the square root of 17 over 2. You can use the quadratic formula to solve any quadratic equation. So just keep that in mind for future reference when you're taking a PSAT or an SAT. Let's try the next one. All right, this is an ugly problem. Now, I don't know if it was last year or 2 years ago, we gave a test question that looked like this. Students were tempted to try to plug in fractions into the quadratic formula. It was a nightmare. I highly recommend you get rid of the fractions and just enter integers into the formula. So I am going to clear my fractions by multiplying all 3 pieces of this by the LCD. My LCD is going to be 12. So I'm going to multiply everything by 12 and clear the fraction. So when I distribute it to the 2/3, notice the 3 and the 12 are going to simplify. So then this is just going to become an 8x squared. Then when I simplify it and distribute it to the next one, the 4 and the 12 are going to simplify. Maybe what I'll do is I'll put a 4 here, and then I'll put, this becomes a 3. So then middle term becomes -3x. And then I have to distribute it to the 3 as well. Nothing to simplify, so it becomes 36. I must get this in standard form, so I need to move the 36 over. You could have moved the 36 over first. It doesn't matter. But in order to get the correct sign on your C, you need to move it over and set your equation equal to 0. Now, my A value is now 8, my B value is -3, and my C value is -36. I now can plug it into the formula. Opposite of B is +3, -3 squared, minus 4 times A times C, all under the radical, and then 2 times 8. 3 plus or minus 9. And again, I'm going to multiply negative 4 times 8 times negative 36. Once I do that, I get 32 times 36. Gives me 1,152. 2 times 8 is 16. I'm now going to add what's under the radical. 1161. Now here's where I use that 4th grade divisibility rules. I want to see if 9 is going to go into this. So I'm going to add 1 plus 1 plus 6 plus 1. I get 9 when I add up the digits of 1,161. So I know 9's a factor of 1161. So it'll actually go in here 1, 2, 2 times 18, 81. So the 1161 is 9 times 129. I use that 4th grade divisibility rule all the time because I want to see if 9's a factor. So then now this simplifies into 3 square root 129. 129's prime, I can't break it down because if I try to add 9 plus 2 plus 1, that's going to give me 12. 3 goes into it, but 9 doesn't. So even if I try to break down 129 and divide it by 3, this actually breaks down into 3 and 43. But again, 43 is prime. It doesn't do me any good. Okay, so now I have 3 plus or minus 3, 129 over 16. Nothing simplifies here. I can't simplify 3 over 16, so I'm done. And again, WebAssign's going to make you pull it apart. 2 more examples, and then we'll practice completing the square. Pretty good? Next one. Always make sure that your equation's in standard form. This is a trick question. Sort of looks like it's in standard form, but remember the x term needs to be in the middle. So if you want to fix it so you can pull out the correct b and c, make sure you do that. So my a is 1, my b is 8, my c is 10. Plug it into the formula. Opposite of b, plus or minus b squared minus 4 times a times c, all under the radical, divided by 2 times a. Simplify what's under the square root. 8 squared is 64. And again, I'm going to take this as a negative 4 times 1 times 10, which is negative 40. Divided by 2. Subtract what's under the radical. I get negative 8 plus or minus the square root of 24 divided by 2. Again, do not be tempted to simplify that negative 8 and 2 yet. Break down the radical first. So 24, factor tree here. Whatever you want to start with. I'll do 4 and 6. I always try to find a factor that's a perfect square. If I'm good at recognizing them, square root of 4 is 2. Factors of 6 are just 2 and 3, no pairs, leave it alone. Negative 8 plus or minus 2 square root 6 over 2. Now I can simplify. So the 2 goes into 8 4 times. So it's a negative 4 now. And then 2 goes into the 2 1 time. So my final answer here is going to be negative 4 plus or minus square root 6. And again, you can pull it apart. Negative 4 minus root 6, negative 4 plus square root 6. And the last example, going to FOIL it. x squared plus 6x plus 6x plus 36 gives me x squared plus 12x plus 36 equals negative 2x. Get it in standard form. X squared plus 14x plus 36 equals 0. Pull out your a, b, and c. A equals 1, b equals 14, c equals 36. Plug it in. Opposite of b, plus or minus b squared minus 4 times a times c. All under the radical, 2 times a. Negative 14 plus or minus. 14 times 14 is 196. And then now I'll do negative 4 times positive 1 times 36 gives me negative 144. 2 times 1 is 2. Subtract 196 and 144. I get 52. Again, do not simplify the 14 and the 2 yet. We need to break down the square root of 52. Square root of 52, if I do a factor tree, it's 4 times 13. This becomes 2 radical 13. So now I have negative 14 plus or minus 2 radical 13 over 2. Now I can simplify. So I can change all of these. Oops, I'm on erase. Put that 2 back. And then now I'll simplify. So this goes away. These become 1s. This becomes a negative 7. So now my final answer, negative 7 plus or minus square root 13 for webassign. Pull it apart. So if I give you a quadratic equation and I just say solve, and I don't specify the technique, if it could be factored, you can factor it and solve. If it is, or you could do completing the square or quadratic formula now. However, on the test next Thursday, I will be specifying for some of the questions which method I want you to use. Probably more specifically, the completing the square. So now what we can do is, if you want to see any of the homework questions worked out, if everybody's good on the homework from last night, then what we can do is I'll make up some completing the square questions for you.